Hello friends, I am Bhavya Bhatt. The purpose of making this video is to help all the students so that they can get the idea how the questions will be asked in JEE mains in class 11th and class 12th physics. I hope this video will be helpful to you. If the video is helpful, then please like the video, share it to your friends and subscribe to our channel. Okay, let us start solving. The question is given like this. In the given question, what they have asked? We have to find the dimension of mass using angular momentum h, velocity of light c and time t instead of using mass, length, time. We have to find dimension of mass. First of all, what is angular momentum? Angular momentum equal to mvr or I omega, correct? In terms of linear velocity, angular momentum equal to mvr. In terms of angular velocity, angular momentum equal to I omega. Here in the question they have asked linear velocity, so we are using angular momentum equal to mvr. The dimension of angular momentum is m for mass, lt raised to minus 1 for velocity, and distance r is having the dimension L. The dimension of angular momentum is m L square t raised to minus 1, and dimension of velocity is, velocity of light is velocity equal to lt raised to minus 1, and velocity of time, you know it already, time t. Therefore, from the question, the dimension of mass is m power 1, L power 0, t power 0 is directly proportional to h power p, c power q, t power r. Therefore, the dimension of m power 1, L power 0, t power 0 equal to, what is h? Dimension of h, m L square t raised to minus 1. Dimension of velocity of light is lt raised to minus 1, power p, power q. Dimension of time t, power r. Now equate the powers of LHS and RHS. First of all, for mass equate the powers. In LHS 1, in RHS p. For length 0 equal to 2p plus q. Then for time 0 equal to minus p minus q plus r. Minus p minus q plus r. Now you have three equations, equation number 1, equation number 2, equation 3. Solve these three equations, you will get the values of p, q and r. Substitute value of p in equation 2, you will get q equal to minus 2. Then substitute p and q in equation 3, you will get r equal to minus 1. Therefore, from the question, m is directly proportional to h power p, c power q, t power r. Therefore, m is directly proportional to h power p, p value is 1, c power q value is minus 2, t power r value is minus 1. This is the solution. Let's go for next question. In this question, work done is given as alpha beta square into exponential of x square by alpha kt. Many times minus x square by alpha kt will be asked, but the dimension is same. We have to find the dimension of beta. First of all, we have to notice that exponential of anything is a constant. that is dimensionless constant because it is a number. Therefore, the dimension of work done will be equal to dimension of alpha beta square. These two, dimension of these two, it will be same, which is equal to dimension of work done is ml square t raised to minus 2. Therefore, consider this term now. Now we have the dimension of alpha beta square, we have to find the dimension of beta. Therefore, consider this term exponential of x square by alpha kt equal to some dimensionless constant. Therefore, dimension of x square by alpha kt is also some dimensionless constant, because exponential, if exponential goes to this side, log of anything is constant. Therefore, the dimension of x square will be equal to dimension of alpha kt. Therefore, what is the dimension of x square? X is the distance, therefore L square is the dimension, alpha, K is Boltzmann constant, joule per Kelvin is the SI unit of Boltzmann constant, joule is the unit of energy, that is dimension is mL square T raised to minus 2, per Kelvin is there and the dimension of temperature is Kelvin. Therefore, L square equal to alpha, here Kelvin cancels, Kelvin raised to minus 1, Kelvin cancels, therefore m L square T raised to minus 2. Next what happens, we have to find the dimension of alpha here, therefore alpha equal to, here L square cancels, remaining is m power minus 1 t power 2, this is the dimension of alpha. Therefore, we know that alpha beta square, what is alpha beta square? ml square t raised to minus 2, ml square t raised to minus 2 is the dimension of alpha beta square. Therefore, dimension of beta square will be equal to m L square t raised to minus 2, dimension of alpha beta square by alpha, m power minus 1 t power 2, which is equal to m by m power minus 1, that is m square, L square t raised to minus 2 by t power 2, that is t raised to minus 4. Therefore, dimension of beta will be equal to root of this m L t raised to minus 2. Check for correct option. Okay, let's go for the next question. In this question, energy density is given. Energy density equal to, it is given as alpha by beta into sine of alpha x by kt. This is the given expression. We have to find the dimension of beta here. Beta is a constant, k is Boltzmann constant, T is a temperature. This question is similar to, this problem is similar to previous problem. Just notice that k is repeated here. From this we can notice that we should know the dimension of Boltzmann constant. Let us try to solve it. Okay, sine of alpha x by kt is dimensionless constant. Therefore, the dimension of energy density means energy by volume, equal to, the dimension of energy is m L square t raised to minus 2 by volume is L cube. Therefore, the dimension of energy density is m L power minus 1 t raised to minus 2. This is the dimension of alpha by beta, this term, because this term is dimensionless constant. Therefore, consider sine of alpha x by kt equal to dimensionless constant. Therefore, alpha x by kt is also dimensionless constant. Therefore, the dimension of alpha will be equal to dimension of kt by x. That is equal to dimension of kt. What is dimension of k? You already know it. Joule per Kelvin is the SI unit of Boltzmann constant. Therefore, ml square T raised to minus 2 per Kelvin. Here the dimension of temperature is Kelvin by distance x having the dimension L. Therefore, the dimension of alpha equal to k power minus 1, k cancels, L square by L is L, m, L, T raised to minus 2 is the dimension of alpha. Therefore, we know alpha by beta. Alpha by beta equal to, we know that alpha by beta equal to m, L power minus 1, T power minus 2. Therefore, dimension of beta equal to m, L power minus 1, ml T raised to minus 2, sorry, by m, L power minus 1, T raised to minus 2. Beta equal to m cancels, T power minus 2, T power minus 2 cancels, remaining is L square. This is the dimension of beta. Here in this question, they have asked the dimension of Pascal second. Pascal second. That is, Pascal is the unit of pressure, second is the unit of time. Therefore, the dimension of pressure into time equal to, what is pressure? Force by area into time. The dimension of force is m, L, T raised to minus 2 by area L square into time t. Therefore, m, L by L square is L power minus 1, T power minus 2 into T, T power minus 1. This is the dimension of pressure into time, that is Pascal second. Okay, let's go for next question. Here we have to find the dimension of coefficient of viscosity. Here F is directly proportional to, viscous force is directly proportional to area and velocity gradient. Therefore, F equal to some constant into area into velocity gradient. Therefore, that constant is nothing but coefficient of viscosity. Coefficient of viscosity equal to force by area into dx by dv, where F equal to mass into acceleration. We can write like this: dv by dt. Acceleration is dv by dt, m by a into dx by dv. Here dv dv cancels. Therefore, mass by area, dx by dt is velocity, which is equal to momentum by area. Therefore, the dimension is p, a power minus 1, t power 0. Therefore, the dimension of coefficient of viscosity in terms of momentum, area and time is p, a power minus 1, t power 0. Okay, let's go for next question. It's better to write the dimensions of all the parameters first. First of all, potential difference. According to the definition of potential difference, V equal to E into length, where E is electric field and L is the distance between the points in a conductor, where electric field is equal to force per unit charge and distance L, which is equal to ml t raised to minus 2 into L by at, where ml t raised to minus 2 is the dimension of force, L is the dimension of L, at is the dimension of Q, because I equal to Q by T. Therefore, Q equal to I into T. The dimension of I is ampere. Therefore, the dimension of potential difference is ml square t raised to minus 3 a power minus 1. Next parameter, resistance equal to V by I, where the dimension of V is ml square t power minus 3 a power minus 1 by dimension of current is A, which is equal to m L square t raised to minus 3 a power minus 2. Next, dimension of EMF. Here dimension of EMF is equal to dimension of potential difference. Next, go for inductance. L equal to minus E into dt by di, because you know that E equal to minus L into di by dt, right? From this, L equal to minus E into dt by di, where EMF is having the dimension m L square t power minus 3 a power minus 1 by di. The dimension of current is ampere and dt is there, therefore dimension is time. Therefore m L square t power minus 3 a power minus 2 is the dimension of, here t is there, so t power minus 3 t power minus 2 is the dimension of inductance. At the last, capacitance equal to q by v, where q is charge, v is potential. Therefore q is having the dimension at by potential difference m L square t power minus 3 a power minus 1 is the dimension of v. Therefore m power minus 1, L power minus 2, t power 4 and a power 2 is the dimension of capacitance. Now we shall find the correct answer using these dimensions. First option is given as root of L into C. Check for first option, which is equal to root of dimensions of L and C. What is it? L, inductance, m L square t raised to minus 2 a power minus 2, the dimension of capacitance is m power minus 1, L power minus 2, t power 4, a square, this one, which is equal to root of, here m power minus 1 cancels, L square L power minus 2 cancels, a power minus 2 a square cancels, remaining is t raised to 2. Therefore dimension of root of LC is equal to t. Go for next option, second option, that is L by R. What is the dimension of L? Dimension of L, m L square t power minus 2 a power minus 2 by R, the resistance, m L square t power minus 3 a power minus 2. Here m cancels, L square cancels, a power minus 2 cancels, remaining is t. Check for third option, CR. Dimension of C is m power minus 1, L power minus 2, t power 4, a square. R is, dimension of R is m L square t power minus 3 a power minus 2, which is equal to m power minus 1 m L power minus 2 L square a power minus 2 t raised to 4 t raised to minus 3, that is t. Check for last option, that is C by R, which is equal to m power minus 1 L power minus 2 t power 4 a square by m L square t power minus 3 a power minus 2. M power minus 1 by m power minus 2 L power minus 4 t power 7 a power 4. So this is not equal to t, therefore fourth option is the correct option. Okay, go for next question. Here we have to find the dimension of power in terms of kinetic energy, current and charge. So let us see the solution. We know that power equal to work done by time. Work done by time. Here we know that work done can be written as change in kinetic energy. Change in kinetic energy equal to work done by time. That is, here in the options are given in terms of current and charge. So we have to notice that we have to use this equation, this formula, I equal to q by t, where q is charge, t is time, I is current. Therefore here time is given, therefore time t equal to q by I, current. Therefore time equal to q by I use capital terms. Change in kinetic energy dimension is k by charge q is having the dimension q by I. Therefore the dimension of power is k q power minus 1 I. This is the dimension of power. Let us see next question. Here equation of the circle is given as x square plus y square equal to a square, where center of the circle is at the origin. Now the center is changed to other than origin. Now new equation becomes x minus at whole square plus y minus t by b whole square equal to a square. Now we have to find the dimensions of a and b. Here we have noticed that x and y are the distance. So the dimensions of x equal to dimensions of at, because this one is also distance. Dimensionally x equal to at. Therefore a equal to x by t. Dimension of a equal to dimension of x by t. Dimension of x is length. Dimension of time t is given as t raised to minus 1. In the question they have mentioned dimension of t is t raised to minus 1. Therefore dimension of a is L into t. Similarly find the dimensions of b. Similarly dimension of y equal to dimension of t by b. Therefore b equal to t by y. Dimension of t is t raised to minus 1. Y is distance, so dimension is L. Therefore dimension of b is L power minus 1, t power minus 1. Let's go for next question. Here there are 4 parameters. We have to find the dimensions of these parameters. First one is pressure gradient. What do you mean by pressure gradient? Difference in pressure by difference in length, or dou p by dou x, we can write like this, where p is the pressure, x is the distance. What is pressure actually? Force by area. So dimensional formula of force is mL t raised to minus 2 by area is L square, and x is the distance. Therefore L is the dimension of distance x. Finally the dimensions of pressure gradient is m. L cancels, so L power minus 2, T power minus 2. This is the dimensional formula for pressure gradient. Next one, energy density. Energy density equal to energy by volume. Energy by volume. What is the dimensional formula for energy? M L square T raised to minus 2 by volume L cube. Therefore dimensional formula of energy density is M L power minus 1 T raised to minus 2. Third one, electric field. What is electric field? Force per unit charge. Therefore, the dimension of force, you know it already, mLT raised to minus 2, charge AT, because I equal to Q by T. Therefore, Q equal to I into T, where I is current, T is time. I, current, is having the dimension A, T for time. Therefore, AT is the dimensional formula for charge Q. So, M L T raised to minus 1, A power minus 1 is the dimensional formula for electric field. Last one, latent heat. L equal to Q by M, where Q is energy released or absorbed during the process, M is mass. What is the dimension? What is the dimension of energy? M L square T raised to minus 2. Dimension of mass is M, which is equal to M power 0 L square T raised to minus. Let's go for next question. We have to find the dimensions of mutual inductance. Here we know one expression related to mutual inductance, that is energy stored in the inductor is equal to half L I square. Correct? Where L is inductance, I is current, and U is energy stored. Therefore, L equal to 2 U by I square. Now we can write the dimensions of L. Therefore, L equal to dimensionally, dimensions of energy is ml square T raised to minus 2 by dimension of current is A square. Here I square is A square. Therefore, ml square T raised to minus 2 A power minus 2 is the dimensions of inductance.